Welcome back to the channel Physics with Cyrus, and in this video I'm going to solve paper 1 of physics, October November 2020, paper 1 2. There are 40 questions in this exam, and each question will score you 1 mark. A heavy nail is fixed. Question number 1 is stating that a heavy nail is fixed firmly to a wall. It is pulled by a string at 40 degrees to the vertical, right? The nail does not move. The nail is not moving. So that means that it is in equilibrium. So this is a very important thing here, right? The object is in equilibrium. 3 forces act on the nail. Number 1 is the weight. You know that the weight is in the downwards direction like this. The tension in the string is in this direction. And the other is the force exerted by the wall, right? So what sort of diagram, which diagram drawn to scale represents the 3 forces? So you should know that the resultant of the weight and the tension would be cancelled out by the reaction force exerted by the wall, right? So the answer for this would be something like this. If you look closely, if I apply the head to tail rule, right, that is going to be like this. So this is the tension in this direction. I'm going to attach weight here. Now the resultant should be where? The resultant should be in this direction, right? It should be in this direction, but you know it's in equilibrium. The resultant should be in this direction, right? But since it is in equilibrium, right, so what's going to happen is that you're going to apply another force which would cancel out this force. So that would be that force which will cancel out the resultant would be in this direction. So the diagram that you would get would be something of this sort. This is the tension, this is the weight, and you have the reaction force R exerted by the wall here, right, like this. So A is the answer to this question. I hope you get it, right? Whenever an object is in equilibrium, you have to make sure that you are, applying and cancelling out the effect of resultant force. Question number 2. A car begins to move. It speeds up until it reaches a constant speed, right? It continues to travel at this constant speed for the rest of the journey, right? It begins to move, and then this is the car. It begins to move. It speeds up until it reaches a constant speed. So then it reaches a constant speed. It continues to travel at this constant speed for the rest of the journey. What happens to the acceleration and what happens to the velocity of the car during the journey? So what you have to recognize here is that the object will first it will accelerate, and that acceleration would change. It would decrease until the object will reach the constant speed. The constant speed means that the acceleration is 0. So there is a change in velocity, and there's a change in acceleration as well. So again, the answer would be A. The other options would be wrong because both of these are occurring, right? A is the answer. Whenever an object moves at a constant speed, you should know that acceleration is 0. Question number 3. The speed time graph for a car's journey is shown, during which part of the journey is the car moving with non-uniform acceleration. It's a speed time graph. You should remember that the gradient of the speed time graph gives you the acceleration. So in A, it's constant acceleration. This can't be true. In B, if you look here, it is constant speed, so 0 acceleration. In C, you know that the speed is increasing non-uniformly, and so there is non-uniform acceleration involved here. So C is the answer. D is the deceleration, right? So C is the correct answer. Moving on. A car is traveling forwards at high speed. The brakes are applied and the car skids along the road surface. In which direction and where does the friction force act? So you know that the car is moving in this direction like this, right? So the frictional force should act backwards on the tires, right? Backward. If you are talking about the tires as a whole, the frictional force should oppose the motion of the object. So A is going to be the right answer, right? Question 5. A car of mass 800 kilograms has a forward acceleration of, this is a car, it has a mass of 800 kilograms and it has a forward acceleration of 2.5 meter per second square, right? A frictional force of 1200 Newton opposes the motion of the car. So there's a frictional force which is opposing the motion of the car, that is 1200 newtons, right? What is the driving force due to the engine of the car? So you should know that the driving force, if it is moving in this direction, the driving force, let's say it's capital F, you should know that the resultant force F minus F is equivalent to the product of mass and acceleration by the Newton's second law. Remember that this is always the Newton's resultant force is applied in this Newton's second law formula, right? So F is the forward force, so it's going to be F minus frictional force is 1200. Mass has been given as 800 kilograms. The acceleration is 2.5. And when you'll do the necessary mathematics, you'll arrive at the answer. If you'll take this 1200 there, you get the answer as 3200 newtons, right? So D is the answer for this. Moving on. Question number 6 is about circular motion, right? So in this question, they have said that the satellite orbits a planet in a circular path as shown. It has a constant speed, right? There's a force on the planet due to the satellite. There's a force on the planet due to the satellite. In which direction is the force on the planet? Always remember that the force is towards the center, right, of the circle, right? But here they're asking you a different question. They're asking you in which direction is the force on the planet, right? You see that the satellite is moving this force on the satellite is in this direction, the force on the planet is in this direction, right? Since they are equal and opposite forces, right? Remember that they are equal and opposite. In a uniform circular motion, you should know that if an object is there, the force on the object is towards the center. But here the thing is that they're asking you in which direction is the force on the planet. So the force on the planet is in the direction B, and this force is equal and opposite to the force on the satellite, right? And that's why we have B as the correct answer, right? I hope this is clear to everyone. Moving on. A block is hung on a spring balance. The marker inside the balance is pulled down by the block. What can the position of the marker be used to determine, right? So you should know that the marker will determine the mass of the block in kilograms. If you say that the mass of the block in Newton, that is incorrect. The force is measured in newtons. Similarly, the weight of the block can be measured in newtons, so that is also absolutely wrong. The moment caused by the block in Newton, that is again wrong, that is in Newton meter. So A is the correct answer. So make sure you know the units pretty well in this for this. This question, there is an astronaut on a planet which has a gravitational field strength 1/5 of the value on Earth. He hangs samples of rock from a spring balance designed for use on Earth. Each sample has a mass of 0.1 kilograms. The spring balance reads 1 kilogram. How many samples of rock are there? So what you need to recognize in this question is that you have the spring balance designed for use on Earth. So the spring balance is giving a reading of 1 kilogram on Earth, right? And each sample has a mass of 0.1. So on Earth, we require 10 samples for this, right? But the critical thing here is that you see that the gravitational field strength is 1/5 on the other planet, right? That is 1/5. So you require 5 times more pieces. You require 5 times more pieces to produce the same effect as that of the Earth, right? So what you'll do is you'll multiply 10 by 5, since you require 5 times more pieces in order to produce the same effect as that on the Earth. So the answer would be 50. Right. Question number 9. An electrically charged plastic ball is at rest. Which type of field are caused by the ball, right? So what you should recognize here is that it is an electrically charged, so it should have electric field. Similarly, you know that all masses have gravitational force, right? So it would have electric and gravitational. Since it's not moving, right? Since it's not moving, you will not have any other sort of effect here. So you have electric and gravitational. Magnetic force is not possible here, right? Question number 10. Which list contains only quantities that can be changed by a force? So you know that shape can be changed by a force, velocity can be changed by a force, and volume can be changed by a force, but mass cannot be changed. So answer is D. An extension load graph is plotted for a spring. Which point marks the limit of proportionality for this spring? So remember that the limit of proportionality is the point where the force is directly proportional to the extension, and that is the limit, right? After that the spring deforms, right? So B is the answer here. After that, you know that the force, the load and extension, they are not directly proportional. It is bending towards the extension axis here. So B is the answer. Question number 12. The diagram shows a diver 20 meters below the surface of a lake. The total pressure at this depth is 3 times 10 raised to power 5 pascals, right? An air bubble has a volume of 0.60 cm cube as it leaves the diver. It rises to the surface of the lake where the pressure is this 1.0 into 10 raised to power 5 pascals. The temperature of the air in the bubble remains constant. What is the volume of the air bubble at the surface of the lake? So in such type of questions, what you need to recognize here is that the pressure of atmosphere is acting here, right? And the pressure due to the depth of 20 meter is the pressure due to water plus the atmospheric pressure, because the atmospheric pressure is also acting here. So I'll call this pressure P1, and I'll call this atmospheric pressure, which is this, as P2, right? They have already given the total pressure at this depth, right? So what you're going to do is that you're going to apply the formula P1 V1 is equal to P2 V2, and when you apply this formula, you will be able to get the volume of the air bubble at the surface of the lake, right? If they only tell you about the water pressure, that is only the pressure due to this depth of water. But when they say total pressure, that means that the atmospheric pressure is added along with the pressure due to water, right? So they've given you the total pressure at this depth. So let's apply the formula. P1 is, I'll call this P1, this is 3 times 10 raised to power 5 pascal, and V1 is 0.6, and P2 is 1 into 10 raised to power 5 pascals times V2 that we need to figure out here, right? So this cancels with this one, and we have the value of the volume at the depth, which is equivalent to 1.8 cm cube, right? I hope this clears the concept. A ball is dropped from a height as shown, ignoring the effects of air resistance. Which statement about the total energy of the ball is correct? You should remember that the law of conservation of energy is being applied here, and everywhere the energy is the same, right? The total energy is the same everywhere, right? Although there are conversions between kinetic and gravitational potential, and if it's moving in air, then thermal energy is also incorporated. But the total energy is always the same. So A is the answer for this question. Question number 14. A student uses an average force of F to push a box a distance of D across a horizontal table, right? The mass of the box is M and the gravitational field strength is G. How is the work done by the student pushing the box calculated, right? So you know that the force is in this direction, let's say, and it is moving a distance d across the horizontal table, right? And they've given you the mass, but the force of gravity is acting in this direction, right? So what you're going to do is that you need to find the work done by the student in pushing the box. So you need to apply the force with the distance moved in the direction of the applied force. So A is going to be the right answer for this.